Okay, class, today we're going to be going over probability, and we have more notes today than we've had lately. So first thing is the difference between theoretical and experimental probability. So theoretical probability is what should happen, right? So if you flip a coin twice, you should have one heads and one tails. Okay, so you're going to set it up as a ratio or a fraction where the favorable number of outcomes is on top and it goes over the total number of outcomes, okay? All right, so if you were rolling a dice and you wanted the probability of rolling a number 1, well, there's only one number 1, so that would go on top, and on the bottom would be 6 because there's 6 sides on a dice. All right, the next is experimental probability. An experimental probability we set up in a similar way, but it is what actually happened. So on top, you're going to put the number of times the event occurred, over the total number of outcomes. So the total number of times they did the experiment. Okay? All right, so the next thing that you need to know is the complement. So sometimes you will be asked the complement. And remember in class we talked about it's like your other half. It's what completes you. It is the outcomes not included in the event. So for example, what if they said they wanted the complement of rolling a 1? Well, the complement in the event is rolling a 1. The complement is what's not in the event. So it would be rolling a 2, 3, 4, 5, or 6, right? So there's two ways to figure it out. Either the probability of the event plus the probability of the complement equals 1, right? So that's how we did it. We said, all right, maybe the probability of the event is 1 out of 6. So what do you have to complete it, right? To make 6 over 6. So it would have been, the complement was 5 over 6. Okay? All right, so the next piece is just to remember that if you want to find the probability of more than one event, so if 2 events or more, you're going to multiply the probabilities. Okay. All right, and the last piece from our notes today is if you have to make a prediction, okay? So to make a prediction, set up a proportion, right? And the proportion will look like this. So the favorable number of outcomes on top over the total, and then you're going to have x over your new total. Okay? All right, so now that we've gone over all of the notes, let's look at these other two situations. So here it says, Julia has a stack of game cards that includes red, green, blue, and yellow cards. She draws a card without looking, records the results in the table, and returns the card to the stack. The table below shows her results for 60 draws. Using the data from the table, complete each sentence. Okay, so the first sentence says, Julia is more likely to draw a blank card than a blank. So you have lots of different options, okay? I'm just going to say she's more likely to draw, let's see, a blue card than a red card. Oops. So, like I said, you get to decide as long as your first color has more outcomes. Oops, why did I do that? Than the second. Okay. The second one says Julia is equally as likely, so we're looking for two equal quantities, to draw a green and a yellow. All right. She's less likely to draw, let's see, a red than a green. She is twice as likely to draw a blank. So what is 2 times the other? So she's twice as likely to draw a blue than a red. That's the only option in this one. She's half as likely, so that's the opposite. She's half as likely to draw a red than a blue. Okay, and the last one, she's 2/3 as likely to draw a blank than a blank. Okay, so for the 2/3, you're going to want to set up a proportion and say that, let's see, 2/3, and I'm going to go with the 15 and the 20. So 15 and 20. Is that equal? If I divide this by 5 and divide this by 5, I have 3/4. Okay, that's not equal, okay, to 2/3. So let's try 2/3, and let's see, we had a 10 and a 15. Let's try that. 10/15. So if I divide by 5, I have 2/3. So that's right. So the first blank is going to be the 2 or the 10. So that can either, or that has to be red. And then the second blank is the 3, has to be the 15. So it can either be green or yellow. All right. Let's take a look at these down in the bottom over here. So it says, look at the spinner below. Write a statement that compares the likelihood of spinning a 1 and the likelihood of spinning a 2. All right, so the probability of spinning a 1 is, let's see, 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So 2/8, so I'm going to simplify it to 1/4. And then the probability of spinning a 2, there's 1, 2, 3, 4 2s. So the probability of a 2 is 4/8 or 1/2. So a statement that compares them could be that the probability of rolling a 2 is greater than, right, because 4/8 is bigger than 2/8, the probability of a 1. So the next one, it says, write a statement that compares the likelihood of spinning an even number to the likelihood of spinning an odd number. Okay, I'm going to go ahead and okay. Apparently I'm not going to erase these. All right, we're just going to work with it as is. So an even versus an odd. So even, here's 1, or sorry, I'm circling odds. 1, 3, 1, 3. Okay, so the probability of an odd is 1, 2, 3, 4. Is 4 out of 8, right? Which is 1/2. And then even is 4 out of 8, right? Even 4 out of 8, it's all the 2's, it's 1/2. So the probability of an odd is equal to the probability of an even number. All right, let's look at the last one. The last one says, write a statement that compares the likelihood of spinning a 1 and spinning a 2 or a 3. Okay. Words, baby. What? You want to sit with me? Okay. So the probability of spinning a 1.
I love you, Mommy.
I love you too, baby. We already said the probability of spinning a 1, right? So it was 2 out of 8, or 1 over 4. And then the likelihood of a 2 or a 3. So probability of a 2, or a 3. Let's see, we have 1, 2, 3, 4, 5, 6. So 6 out of 8, or 3 over 4. Okay, so the probability of spinning a 2 or a 3 is greater than the probability of spinning a 1. All right, let's go to the second set of notes. Y'all come back and work on those problems a little bit later. So here it just says to match each vocabulary word with its definition. So experimental probability has experiments in it. So it's going to be the number of times an event happens over the number of times an event is done. And then the other one is the number of favorable outcomes over possible outcomes. Okay, so let's go ahead and look at these together. It says that a coin is tossed 2 times. What is the probability the coin will land with heads facing up both times? Okay, so the probability of rolling a heads is 1/2, right? But we want to do it twice. Darn it, why is it erasing? Hang on. Okay, so the probability of flipping a coin for heads is 1 out of 2, right? But they say both times. So if it's more than one time, you're going to multiply the probabilities. So it's 1/4. Is it theoretical or experimental? Well, in this case, it's what should happen, right? So it's going to be theoretical. All right, next one says, a screening of 1,200 boys, teenage boys, shows 15 have high blood pressure. What's the probability that a boy will have high blood pressure? Okay, so we want the number with high blood pressure, so 15 over the total, 1,250. And then they want to know if it's theoretical or experimental, okay? So, but first we need to simplify. So I can divide both these numbers by 5, and I know that because they end with a 5 and a 0. So it's 3 over 25. And I know that because I did 1250 divided by 5, and I got, over 250. Okay. Right, 2 is 10, 25, 5, and 0. All right, and this one is going to be experimental. So I want you guys to go ahead and try the next few, and then you can press play again and check them. So the first one wants 1 or a 4, so there's 2 out of 5 sections, and that's theoretical. The second actually has data. They actually asked people, so it's going to be experimental, and the number that wanted a movie after the meal over total. All right, so now I'll show you what your problems are for today, and you're going to enter your answers in Schoology. Okay, guys, so these are your problem numbers. We're going to skip the bottom 2 on the first page. Make sure that, excuse me, make sure you're inputting your answers on Schoology. Have a great day, guys.